Good evening. This is that one guy broadcasting from sunny Holland. This is going to be episode 9 of KSP for Beginners, and we're finally actually going to head over here to the vehicle assembly building for spaceplanes, also known as the spaceplane hangar. However, again, we're just going to start off with one of these two cockpits. I highly recommend the Mark II for this reason. You can go to Structural, grab an NCS adapter, then go to Control and put on one of these fancy little avionics packages. Pretty cool, nice, self-contained, makes a nice nose. However, if we use the Mark I, well, we are straight out of luck, Charlie, because this does not go anywhere on the front of this thing. And this is definitely the SAS you want, because this is more for locking you onto a bearing and keeping you there, which does not bode well for me in landing. So, personal preference, I like Mark II cockpit. Doesn't have the internal spaces done, but that's a small price to pay. So we're going to be talking about a couple of things today. First things first, just building something that will get you used to flying. You're going to do this whole Mark II NCS setup. Then we're just going to build a simple, we're going to need a couple of these. They're Mark I fuselage jet fuel. They're a little bit lighter than normal fuel tanks. We're going to go to Aerodynamic. I'm going to go ahead and put a tail connector on this. Tail fin, not really. Then we're going to go ahead and I'm going to build up one of these. Put one of these on the back of that. I'm going to go ahead and turn on the symmetry. Now let's bump this back just a bit. There we go. I'm going to go ahead and turn on the symmetry. I'm going to go ahead and grab up the circular intake there, and then I'm going to grab up basic jet engine and put that here. Now this is a pretty basic setup for an airplane. I'm going to do a couple of things to show you how to convert this into a space plane. First things first, you're going to want to channel your fuel out to your engines, so we're going to set up like that. Grab up the aerodynamics. I'm going to put on a delta wing on each side, and you'll notice this isn't radial, it's actually bi-symmetry, I'm not sure, mirrored, I believe is what they call it. So you're going to need a couple of things. First, you're going to need some wings. I like these, they produce a really ridiculous lift, and lift is this weird thing in this game where they don't even really have to be facing a certain way. Mind you, yes, it's a bad idea to put it 90 degrees to the direction of travel. That is to say, like that. But pretty much lift is just, if you have it, your plane will rise as long as it is competently built. Next, we're going to grab up a tail fin. I'm going to put one-time symmetry back on. 1 second. Oh, that's adorable. That one gal is going to bed, so I'm just going to text her goodnight. Sweet. Alright. Back to tutorializing. We're also going to grab up a small control surface, and using the whole WASDA commands, we're going to line it up like that. Now you notice I did the same thing over here. That is because these wings actually don't come with control surfaces. I'm going to turn the symmetry back on and make this sort of a Predator drone tail fin. I think it looks pretty cool. Next, we're going to go over to the utilities. We're going to grab up a small gear bay. And we're going to turn off symmetry, put one there, turn symmetry back on, put two right there, and bam, there we go. That is a jet. It's got a fairly decent range, so let's go ahead and name this the Trainieren 1 for trainer or training, because I know a tiny bit of German. Deutsch. Now we're out on the runway. We got Jebediah Kerman in the captain's seat. So what we're going to do is we're going to turn on the SAS. We're going to turn on precision controls and throttle up to 100%. We're then going to hit space. But here's the fun part: the WASDA QE control setup actually works without having to turn off the SAS. Oh, I lied. Ha! I forgot one thing, so we're going to go ahead and hold B as the brake. And I'm going to slow us down, hopefully before we hit the end of the runway. And boom. Forgot one very critical element to plane building in this game, and that is you're going to need these canards. Now, I found that putting the canards on the front of the plane, like so, make it much more responsive, as the atmosphere, by comparison to our atmosphere, is like soup at sea level. So this, especially for gliding, helps out a lot. So we're just going to go through that same pre-flight, 100% throttle, precision control on. Here we go. I was wondering why we weren't lifting off. Basically, this is your elevators, except instead of being on the back here, I've put them on the front, and it works pretty good. See? We're going up. You hit G to bring in your gear. The gear comes up. Sweet. So we're just going to go ahead and fly a second. We're going to drop that down to 80% so that we're not going to blow up our engines. Whoa, Christmas, wow. There we go. Alright, and then we're going to head out to that island over there. So I'm going to shut up, put on a little music, and we'll do a little flyby. Well, actually, you know what? No, I lied. I'm sorry. I'm going to go ahead and just tell you a couple of things. Number one, there's actually a way to adjust the natural pitch of the airplane. This thing that I've made is actually pretty balanced right now, but how you do that is you hold Alt, and then you hit whatever you want to correct, either roll, pitch, or yaw, and that will automatically correct that much, and that's for balancing out your aircraft. I don't actually play with that, I just mess around with the SAS and call that good. So it's pretty easy to fly. The controls work pretty well. The Q and E will still roll you. WASDA will rotate you. WASDA will cause translational movement along the nav ball. So as long as you're thinking in those terms, you're going to be okay. I don't know what that was. So what we've got is we're just zipping along in a jet, la-di-da-di-da. So just fly around a little bit. A really good target that you might find interesting is out here. We're actually heading out to the second runway that is close to Kerbal. We could head out to the second KSC, but that requires a much bigger plane than I have made right here. This is just a little pond hopper to get over there. A couple of other things as far as landing goes. I've found that it's much easier to land with an unpowered glider than it is to land with powered up engines. And this differs from real life quite a bit, as it is very easy to land with powered up engines. Otherwise, pilots would shut off the engines right before they landed. There was actually a time in my childhood when I did want to be a commercial airline pilot, but then I thought better of it, and I'm quite glad that I did. There's nothing that I have against commercial airline pilots. They're wonderful people, and I know a couple of them, but it's just not for me, I guess. Just like physics wasn't for me, which is kind of funny. Anyways, we're going to be coming in. You should be able to see the runway coming up here. So I'm going to go ahead and we're going to cut the engines. Then we're just going to use our momentum. And we might have to power up the engines again, but I'm going to try and glide down to that runway. And there is an Easter egg over here, so actually I'm going to power back up because I'm not going to make it there. And here we go. Jet engines are fiddly in that they take a little bit of time to turn back on, but the beautiful thing you'll notice is that I am not even close to burning through fuel at a fast rate or anything. And as long as I stay relatively low in the atmosphere, I'll be fine. So we're going to hit X and shut off our engine again. This is not the optimal this is not the optimal profile. I'm going to hit G to go ahead and lower the landing gear. So we're going to try and land on this runway. One thing about this particular runway is it is elevated from the surrounding land, whereas the KSC, it is also elevated, but it's not nearly as elevated as this. So we're just going to adjust ourselves and come in. And you'll notice that I'm trying to keep myself at roughly less than 10 meters a second. So touchdown F. Oh, geez, gloom and doom. I'm going to hold B. F can go back on. And there we go. Second KSC. We've got old. I think we've got the old parts rotting over here. You can probably see them, but I'm not getting Jeb out because he's never getting. Holy crap! He's freaking out. What the heck is wrong with this picture? Alright, whatever. End flight. That's creepy. So that's step 1 in this little part 9 of KSP for beginners is build something like that, fly around with it, get used to the plane controls, because if you don't, this next little part is going to be an absolute right pain in the arse. Next, I'm going to start off with that same cockpit setup, and I recommend using whatever cockpit setup that you used, either the Mark 1 or the Mark 2. Again, I prefer the Mark 2. Next, we're going to go to Utility. We're going to do an inline docking port, because if it doesn't have a docking port in this game, basically it exists in its own little pocket dimension. And by that I mean you can't dock with anything. Now, I've actually worked out a pretty simple formula for small SSTOs like this. I haven't worked out the formula for the bigger one yet, and I don't know if you've come from my KSP for Beginners tutorial page on the KSP forums, but I'm working on figuring out how to do bigger craft than this. The biggest that I've got is something called the Jagwasp. The SSTO Jagwasp, I might post the craft file in the link, we'll see. But it follows the same basic principle. What you're going to need is you're going to need a Mark 1 fuselage. Let's see. You're going to need one of these with the stripes. Then you're going to need some of these. You're going to, in the aerodynamic, need the ram air intake. And you're also going to need the turbojet engine and one of these Torridial aero spikes. Now, the reason we're going to... Oh, also some RCS, but we'll get to that in a bit. Now, the reason that you're going to need all this stuff is it's all the basic components for your new spaceplane. So first things first, you're only going to need one of these per this setup I'm going to show you the math on. Well, not really math, but I'm just going to show you the formula I worked up. You're going to need one of these per every one of these to get you into orbit for the mass. This setup right here will drain out into this toroidal air spike, and you're wondering why I've got more fuel here. Well, it's because back here, I'm going to hit X, each one of these engines is going to have this oxidizer fuel mix. Now it's a jet engine. I'm going to put the RCS there. It's a jet engine, so we're going to need an air intake of some sort. Now what we're going to do is we're going to put on some external fuel ducts, like that. Now this is a basic fuel setup for an SSTO. A lot of craft are based off of this, including, like I was saying, the Jagwasp. My craft, the Hornet, actually looks very similar to this. What the heck is it called? Ares 4A stock. That is another SSTO that uses this very, very same... Sorry, my throat's a little dry. Very, very same formula, because what happens is these engines burn through roughly 150 liters, or one Mark 1 fuselage jet fuel, to propel yourself up to the proper altitude before you can kick on the aero spike. So yes, let's go ahead and quickly build a jet wing structure and body around that, put on some RCS, and let's do this. Pull this back. You know what? No. Let's grab up some of these, grab up this, and boom, cool. Yes, that does look quite a bit like the Hornet. The major difference is I'm going to go ahead well, the major difference is this has a little bit more RCS fuel than the Hornet, and the tail fin structure is slightly different. Let's go ahead and name this thing... No, I need that for an actual project name. Let's name it... the Antlion 1. Save. And let's see, we're going to need some RCS. Now the RCS... boy, oh. The RCS is going to be a little bit tricky. I'm going to put one there. I'm going to go ahead and drop one there and there on the wings. And let's see, I'll drop 2 here. That way we have relatively close RCS thruster block coverage. I'm going to hit the cockpit, tap Q twice, put it back down. And I'm going to go ahead and turn off symmetry mode again. Well, I'm turning symmetry mode on, so I can do... That is not even close to what I wanted. So I can do that. Turning symmetry mode back off, so I can do that. Excellent. Now this craft will be able to maneuver around using RCS in orbit, and will therefore be able to dock with things. Let's keep it flipped over. Next, while we're under here, we're just going to install some landing gear here. Now one thing you could do, and I'm going to do, is I'm going to install this, an XMG50 radial air intake, and I'm going to install it right here. That's going to give us a little bit extra oomph in the upper atmosphere, and there's going to be some numbers that I'm going to throw out at you. The numbers are, for every one of these, the amount of air intake you need is 0.06. That means when you're up in the upper atmosphere with this, if the air intake, and it's going to be up in the resources panel, if the air intake falls below 0.12, that means these are going to experience asymmetrical flameout, because I have never had a flameout where all of the engines flame out at the same time. But that's getting ahead of ourselves. We're going to need to create another stage. Isolate the rockets and drop them down, then make them stage 0. That way the jet engines are lighting off first. Next, we're going to play around with action groups. Go down to Custom 1. We're going to go ahead and click the air intakes and toggle those. And we're also going to click the jet engines and toggle those. Now, for all intents and purposes, yeah, that's right, I learned from the comments. For all intents and purposes, this here is going to start with the jet engines. It's all going to have the intake. When we hit 1 in the upper atmosphere, it's going to shut off the engines and the intakes, meaning that the air-breathing system will be offline. Custom 2, I like being able to toggle that with a key. And toggle means it opens up the radial thing. The last thing that I like to do is I like to have my action key 3, excuse me, I'm sorry, be toggle the landing lights, which means if I'm coming down at night, I can go ahead and hit 3, boom, I have landing lights. So, let's go ahead and learn how to fly this thing. Let's go ahead and save it up, because I think that's all I'm going to need. Yep, let's launch. Now, flying one of these things is pretty simple. I will admit right now that this is the same... Yes, that is why we always look our plane over before we take it out. Forgot to put on some control surfaces. In fact, I forgot to put on a lot of control surfaces. Too damn excited to fly this thing that kicked it out the door before it could brush its teeth. Cool, there we go. That's what we want. Remember, the forward things are your elevators. These right here are your elevators. These are your ailerons, and that's your rudder. So let's again go through that pre-flight process, except this one's going to move quite a bit faster. So we're powered up. I'm severely hoping that this doesn't bite me in the butt, because this is literally just a design I threw together and we're going to test. But like I said, I think I've cracked the design nut on small SSTOs. So you're going to go ahead and come up to a angle of 45 degrees above the horizon, And you're just going to keep yourself there until you hit about 10,000 meters, then you're going to level off to 20 degrees above the horizon at heading 090. And the reason for this is you're going to want to pick up a lot of speed. I'm talking we're going to be covering about a kilometer a second once we get up to the atmosphere, and that's with once we get up to the upper atmosphere, and that is without rockets. That is strictly high-performance jet engines. Now you're going to be tapping the keys a lot, so it's not going to be the smoothest flight in the world, but it will get you into space on a single stage. And I honestly can't guarantee this will get into space, but if it does, I might drop it for a K prize, although I might not because it's way too similar to my Hornet, and I don't want to keep proliferating the same SSTO over and over again. This flies quite a bit similar to the Ares 4A, as all space planes now fly very similar. My old space planes in .16 were basically just rocket-powered planes that apparently I was using a glitch that I didn't even know existed to fly. Yep, that's how things roll. As you see, we're not really doing better than 167 meters per second right now. But that's not a huge deal. As long as we are continuing along this particular path, we'll be fine. And the reason I'm not dropping out and adding music is because I'm pretty sure that if, again, you are a beginner watching this series, this is going to be an entirely alien concept to you. Alien. Alright, so we're coming up on the last 1,000 meters. Wow, this thing really likes to pull up. We're coming up on the last 1,000 meters, so I'm going to go ahead and I'm going to do some stuff to drop us down to 20 degrees above the horizon. Oh, there we go. That stabled off a little bit. We rising on that? Oh, indeed we are. Okay. So we're going to keep ourselves here and have a nice slow climb up to about 20,000 meters, but that's not actually what I'm watching. What I'm watching is right here, the air intake. I'm trying to keep that. You know what? There we are. There. I did just use. Oh, no. There we go. There we go. I used that Alt and then W command that I was telling you about in order to stabilize this plane. It is pretty useful. Oh, I did a little too much. Let's bring that back up a tiny bit. Let's drop that down, and there. It looks like I've done it. And then Alt-X will just reset all of that, which you're going to want to do in space, otherwise you're going to be flipping end over end. Now, what I do is I usually wait until about 0.2 air intake units until I level down to 10 degrees above the horizon, and then we just pick up a lot of horizontal speed. As you see right now, we're almost 500 meters per second, and we're still climbing at a pretty good clip. Jebediah is smiling again, so all is right with the world. And I guess my legendarily bad landing skills with that trainer jet weren't enough to scare him away from piloting forever, although I'm pretty sure he caught the last ferry back to the KSC from that island. Yep. Fun times. We're getting into the upper atmosphere now, and the contrail that we're leaving is pretty long, but I'm pretty sure we're out of range of anybody or anything that would want to be catching up to us. Now, let's see. I'm going to take this time to go to the map view and pull this up for later. We might rendezvous with the station. We'll see. We'll see what I think we can do with this craft. Oh, okay, there we go. I'm at 0.24, which is roughly well, it's actually only 0.12 above what I need, so I'm going to drop down to 10 degrees above the horizon. No. There we go. I reset all my control paradigms, and as long as we don't start dropping, looks like I'm going to have to sit pretty at about 15 so that we continue our upward climb. But these ram air intakes do a pretty good job of keeping us steady, and There we go. That was a weird sort of hiccup. These ram air intakes are doing a good job of keeping us steady, and as you see, our speed is 839 meters per second. Goodness. Oh, that one guy. Learn your terminology. So now we're getting up to the point where the jet engines are actually moving fast enough that we're sucking in air just by running into it really fast, which is actually a technique that they're looking into. It's called, what the heck are those things? Scramjets. Apparently, the idea is run into the air really, really fast so that you can go faster. Is as far as I understand it. But again, I'm not an engineer, nor am I a physicist. I am a historian, indeed. Now, what I'm going to do is when we hit 1 kilometer per second, good, I'm going to go ahead and I'm going to turn on the RCS just because we're in the upper atmosphere and I don't want to get knocked off course. So, alright, we're getting pretty close. Here we go. I'm lighting the rocket. I'm hitting 1. And I'm going to go ahead and bring the craft slowly, is the key word here, I'm bringing the craft slowly up to 45 degrees above the horizon, and that's why I turned this on earlier so that I wouldn't have to mess with it in the map view and I wouldn't get what's called a pancake, which is where your rocket plane flips end over end. Now you'll notice I'm actually losing speed, but I'm increasing my apoapsis. Now when this hits about 37 kilometers, I'm going to level off again, and I'm just going to shoot for the prograde marker. Yep, and our surface speed is in fact going up again, and we're basically using this to skip out of the atmosphere instead of just punch straight out of it. We're using our tremendous horizontal speed to maintain movement along a path, and right now we're just basically pointing more up in order to punch out of the atmosphere. Literally, we are trying to just force our way up enough that we're going to get into nice thin air. Alright, here we go, here we go, here we go, here we go. Alright, once we hit 37, I'm going to level this off. There we go, 37. Here we are. I'm going to turn off the RCS because I should be moving fast enough with the toroidal air spike that I'm not going to need any RCS to keep myself corrected. Now notice, we're in orbit, and we're already up to 1,600 meters per second, and that is 1.6 kilometers per second, and we're going to continue accelerating. We're going to approach more near an orbital velocity while we're still in the atmosphere, which means we're going to want to overshoot our target apoapsis. Now, it doesn't look like we're moving up very quickly at all with our apoapsis, but the thing of it is, we're actually building up to an orbital speed, so when this does go, it's really just going to swing out very, very quickly. And here we go. We're 2,000 meters per second, and we're still in the atmosphere. The high atmosphere, mind you, but it's the atmosphere. So here we go. This design actually might work. Cool. And let's go ahead and bump us up to 105 meters. Now, the air resistance between here and the edge of the atmosphere will bring this down, and it will shrink this periapsis into nothing. But no matter, we're moving at a near orbital velocity, so I'm going to go ahead and compress time through physics warp. I'm going to keep us pointed at this so that we minimize our loss due to aerobraking. And see, that actually dropped us down quite a bit. We dropped over 6,000 meters on our apoapsis, and we're going to continue to lose altitude on that. But the point is, you always want to overshoot because atmospheric drag will slow you down. So if you were, say, aiming for a 75-kilometer finishing periapsis, you would want to aim at least 85 so that you wouldn't accidentally not bump out of the atmosphere. So we're going to speed up until we get to the apoapsis. And no, we're not going to do a docking mission, as I'm pretty sure that would strand this craft out there. This is a very nuts and bolts sort of thing, and it doesn't have really any, I don't want to say go-around capability, but that is exactly what I'm talking about. But here it's nice. We can keep our engines on relatively low thrust until we punch the periapsis out of the atmosphere. And here we go. X. We've got a nice sort of circular orbit. And we are going to go ahead and do this. Excellent. Let me see. Above us is the sun. We are just in orbit right now, and we've got quite a bit of fuel left. Not, you know, getting out to the mun or anything, but the beautiful thing about this design is if we hit 2 and then roll our craft 90 degrees either way, our docking port is actually facing towards the normal, so while this is going to flip end over end in the direction that I lied, it's going to flip end over end this way. It's going to flip end over end this way, but this will always be pointing to the north, so that if we wanted to send up something with a lot of fuel, we could dock it, refuel it, and then this is pretty much good to go anywhere in the Kerbal system and back. Just because that's actually quite a bit of fuel to have in orbit. So yeah, let's go ahead and close that up. And I'm going to go ahead and speed up time just a bit. Okay. Now what I'm going to do is when I get there, when I can draw a straight line between this peninsula and this craft, I'm going to go ahead and roll over to bearing 270, and then I'm going to have my cockpit face the ground, because that means all I have to do is I will be facing the right, well, stuff. Just make sure that you're, for all intents and purposes, yeah, see, I did it again, upside down. You're going to then throttle up, and you're going to drop this down to about a 10,000 meter periapsis. This is going to allow you to come into the atmosphere, and I'm pretty sure that'll put you at the KSC. Mind you, I have not done this in a while. I've literally just gotten back into building space planes again. But like I said, I figured, you know, I cracked the small space plane design nut challenge, and I'm not saying copy this design word for word, but a lot of your designs, especially if you follow this whole fuel setup for small space planes, are probably going to look something like this. Now what we're going to do is we're going to roll over, because we're just going to come into the atmosphere nice and easy. And we're just going to point at the prograde vector marker. Yes, I know physics, kind of. I'm going to speed up time until we get to about 73 kilometers. Yeah, there we go, 73 kilometers. Then what we're going to do is really counterintuitive to real-world physics because of re-entry heat. We're going to point our nose right at the direction of travel. If this were a real spacecraft, this would probably burn us up upon re-entry. Yes, that one guy. You should probably go to bed. So, yep, here we go. We're coming back in. And, you're going to be tempted to time warp this, but I wouldn't, in that I've never had a time warp where I was just impatient and I time warped. I've never had that end well. Okay, I shouldn't say never. I had it end well kind of recently, but it was hit or miss. My craft almost shook itself apart. So here we are. We're coming in over the high desert here, and then we're going to go across this and hopefully land right about here. This is shrinking nice and slowly. Yeah, alright. Now the other thing is I have not deorbited from this low in a while. Usually it's from 125 kilometers or better. And by better I mean more. It's not like we're completely out of luck. We do have a little bit of fuel, not really enough to do stuff, But I'm going to panic right now and go ahead and bump this back out to 10 kilometers. Yeah, that seems like it was a good idea. And it didn't use up that much fuel. Cool. And we're still increasing with our speed, so we're good. Basically, like I said, just keep this pointed at the prograde. This is going to take a little while, so I'm going to shut up and I'm going to time compress, and I'm going to put on that sort of tango-y building music that I like. Okay, and at this juncture, I am actually pulling up a little bit so that I aero brake and slow down. But what I don't want to do is pancake, so I'm never really going more than 20 degrees above my prograde. Beyond that, I'm also going to try and bank a little bit because I'm heading towards the mountains, and I'm clearly not going to make it over. So I'd much rather land in this plainsy sort of area than out over the mountains, because number one, they will never ever find me. No, crap. That's what pancaking is. It's very annoying. Come on. There we go, come on. It's annoying, and it's hard to get control back of your craft if you aren't careful. So let's go ahead. And banking is much easier at much slower altitude. So let's go ahead, and while we fall, let's fall over towards bearing 180 and bank back just a little bit. There we go, that's some nice fertile plains right there. We're going to level it off. And we're going to hit G to bring down the landing gear. And because it is night, I'm going to hit 3. I said I'm going to hit, I'm going to hit 3 to turn on the, there we are, lights are on. Just very hard to tell because I'm over 3 kilometers in the sky. So we're going to go ahead and point our nose towards the ground. And one thing that I'm going to do is I'm going to get down to about 1,000 kilometers, and this is a way to hit the runway if you remember all of the stuff to get there. Hooray. We're going to point at the ground at about a 20 degree mark, and that's still going to slow us down, but it's not going to be the rapid deceleration that we're used to with, say, a capsule, where we hit terminal velocity and then we just pop the parachutes. Nope. This you're going to have to glide in and then do a little bit of flaring and then some fun stuff to land. So we're getting down to the point where I'm going to want to start pulling up a little bit in order to pull our prograde vector up, because again, when I get closer to the ground, I'm only going to want to be doing a little less than 10 meters a second. And this is what our craft looks like coming down. Pretty cool looking. So here we go. Oh, there we go. Landing lights. Awesome. As long as I don't hit any really big hills, I'll be fine. So naturally I'm heading towards the duny, hilly sort of area. That reminds me of Grandmere. But, yep, that's pure Michigan for you. Alright, here we go. I'm going to pull up so that our downwards angle up here in the vertical speed indicator is between 10 and 5. And again, when I hit the ground, I'm going to go ahead and let go of F so that the plane will do what it naturally wants to do and drop down towards the ground. So here we go. We're going to be touching down here in a second from a nice orbital flight, even though we didn't even complete one orbit. In retrospect, whatever. Touchdown, F. Whoa, whoa, what in the heck? Man, this thing is just so good at having being airborne that if I let go of F, it's going to try and pop up and back over. That would be an embarrassing end to this mission. But yeah, that's the basics of space planes. It takes a little while to get used to, but the SSTOs are definitely the way of the future that you're going to want to tinker around with. Rockets are still way easier to take care of, and you can get more fuel up into the air with them for right now. But eventually, if you come up with a way to do that, when the actual game, by game I mean career mode, kicks in, you're going to have a much, much cheaper time because all you're going to need to do is just fork out for fuel. This has been that one guy. Thanks for watching.